All right, gonna move on. I forgot to cover just one more thing in this one. So we all know now what is class, what is the concept of it, right? It's kind of setting up a type and properties of an object and making all the values open for anybody to create, right? Right. I wanna just mention about one thing, about the method for class, for an external class. So I'm going to make a class called walk. I want people to be able to, walk or jump, like this determines method is like an activity. It's not a property, but these are more like properties, right? So these values are properties, but you should think about method as more like an activity, an event. So in the walk method, what I'm gonna do is I'm gonna let the velocity to add up to location here instead of from outside. So if I hit walk, my location should be refreshed and increase by the velocity. All right, then going back to this main script where we are calling this human, what we want to do is instead of using this line, change activating the location from outside. I want this thing to just do it inside. We just call it walk. It should be a public variable. That once this walk is called, why is it erroring? Oh, when I call a method, I need to have a bracket. If I have to pass any number, like the previous one, like, yeah, then you add it here. You can also add the numbers, variables here that you want to receive from outside. That's it. So that is the method of a class. Okay, good. I'm going to close this too. So in the script, we only have this example. That's fine. I'm gonna make a new scene. Basic building, that's fine. Create, okay, I'm gonna change this name of the scene, save scene as, save it inside scene folder. Let's say boy. You don't have to name it like that. Doesn't matter. Okay, right click. I just wanted to show you that it's starting from complete scratch. Create empty voids. Right click, reset. And inside scripts folder, or let me just make another folder just in this case, for this case. Make a new folder called void scripts. Just want to show you what consists this script, but you can also save it in the scripts folder as well. The folder doesn't really matter. Okay, right click. Please create three scripts, and one, call it void agent. Right click, call one void system. By the way, void is a shortcut for bird and Android. So it's void. Void. Voice. This is going to be my main menu. Okay, we have these 3 scripts. What I'm going to do now is, let's say, so I have a void. This is going to be connected to this game object, like the main script, all right? And then I'm going to call from here. This is a Unity interface, because this is going to be the mono behavior script. And then this is a pure class called void system. In here, I'm going to do all the calculations of vectors. I'm going to get all the vectors, but there's not going to be any geometry, right? So all the transform, cube, and everything, those are Unity only, right? But this system can be translated to other platforms such as Grasshopper, for example. It's of course some like vector, for example, needs to be changed, but it's translatable. But this is we want to separate the syntaxes for only Unity as a Unity interface. That's why we are using 3 classes. So in the system, we are managing the all the agents, and then we need the agents. So for example, if this were human, we have a human class, and this is a class as a class, yeah, as a group. And then in the voids, the first one, it's only using those information and translate that to Unity geometry. That's why we have 4, or we have 3. Is that system kind of understandable conceptually? Okay. Don't worry about it if you don't completely understand everything. We are all coming from different perspective and different points. You will get there. Okay. What? Empty. Yeah. All right. Let's make another prefab though, that I wanted to have a direction. So let's make a new prefab. Let's make a new cube. We have capsule, cylinder. Let's make a cube. And the direction of rotation, the look rotation we had in the quaternion we just learned, right? That one is pointing to Z direction. That aligns always the Z to that vector. So that's why we need to set this. And then I'm going to, what I'm going to do is I'm going to create a empty object. So this is basic agent geometry. The reason I do this is that I want this, the transform of the parent to be clean, 0, 0. And then I'm going to child this cube under this thing. You'll see why I do this. And then inside here, I want this Z direction to be a little bit longer. So I see this direction. I'm gonna make it to 2. all right? But if I go back, my parent numbers are clean. That's why I made a parent, all right? And then I'm going to make this one as a prefab, all right? But I would love to have some color, so I go back and you can always change this to something else. Is that okay? And once I have the prefab, I'm going to delete it from the scene. Is that good? Okay. And let's go to the script, void script. And in the void, connect the void script here. Is that okay? No? So we have three, we just have three empty scripts. We didn't write anything yet. Correct? So now what I'm gonna do is I'm going to open all of this. So void system and agent. And here I'm going to show you, I'm gonna put this one all the way left just to show you the hierarchy. So void is the interface to Unity. It's the mono behavior one. And in the system, please delete all of this and this. It's going to be my pure class. Similarly for the agent as well. Delete everything. Do you remember how we made the human class? Do you remember that? Is everybody good? Is everybody okay? Yeah, okay. So in the void agent, I'm going to create the construction. All right, public void agent. And in this agent, I want to have some properties. Firstly, it's the position and velocity. Public vector 3 position. Public vector 3 velocity. Do you remember this from human? For human class? Okay. In here, similarly, we do vector 3 lowercase position, vector 3 lowercase velocity, and then pass that on to the global variable. Okay. And then we are going to make a public variable called void update. And similarly to our walk method, do you remember? I'm going to let the position to update here. Position plus is velocity. Sorry. Capital. Is that cool? Okay. don't worry about following as long as you can understand, it's good. All right, follow me because now we are switching back and forth different tabs. And make sure that you always hit save all. All right, and then, so now we have agents. Agents have two properties and one movement or one method. All right, let's go back to our void system. Here we are going to create a lot of void agents. But before that, we need to set up the constructor of void system as well. In here, we are going to determine the size of the agents. So we are going to get int agent count. And what's happening in the construction within this parenthesis is when this void system is created, it's going to run this part, whatever is inside this parenthesis. So what I'm gonna do is I'm going to create a bunch of void agents according to the count that is received from outside. Which means I'm going to make a for loop. I is smaller than agent count. I plus plus. And within this, I'm going to create the void agent in random position. So do you remember how we were making the method of generating random vector? So the script that we just did, I believe, was this one. Do you remember this one? So I have a script that has some useful functions like this. So I'm going to share that, and I hope you can also just use this one. So just go to the team and download this one. Download this one. Let me show you what that is. So it's another class, but it's only with bunch of methods. And in this method, the first one is making random vectors. Second one is making a random unitized vector, unitized two-dimensional vector, and so on. Oh yeah. Let me show you. So copy this one, and then in my case, I copy this on my desktop, and then drag it here. We could have written it also together, but these are not, doesn't change much. So let's just use this one. You can always just copy paste it. Oh, it's not here, sorry. You can move it to inside void script. Okay. So once I have that, I'm gonna have that also open. This one, I'm going to just purely use it. So in this one, I have this get random point function with minimal maximum range, which is convenient. Like we just wrote this earlier, right? Okay, we're just gonna use it. So go to our void system. We are going to create two random vectors. One is position, one is vector. vector 3 position is utilities. Now, since we have dragged that script in, now you have this access. Say dot get random point. And then we will set up a range for X, Y, Z. So I'm gonna set up 0F, 30F, 0F, 10F, 0F, 30F. So it's not too tall, it's kind of a chunky. Make sure you have 6 different numbers. Vector 3 velocity is utilities dot get random point. No, let's use this one. Get unit vector for 3-dimensional one. And then you can times some number to determine the speed. So this is a unit vector. So maybe 4 might be too fast. So let's see. Okay, and then we are going to use these two to generate the void agent. So void agent, which is the one that we just created, this one. In order to make this, we need 2 information. One is position and velocity. That's why agent is new void agent. We need a position and velocity. And then we need to have a list of void agents. List of void agents. New. So once everything is created, we add them to the list. All right. So this actually helped us to create. So how do we use this one? So go to your voids, the main script. And we are going to make a void system. And we are gonna call it void system, lowercase system. Okay. And then inside start, we are going to create a new void system. What do you need for void system? Agent count, right? So if I want to make 300 of them, I'll put 300 there. So do you see the relationship? So in the void, I only call void system. I'm not gonna call agent. I'm not managing agents from here. I'm managing all the dirty agents inside void system. And from outside, we only call the system itself. You see the relationship between different tabs? So from this one is mono behavior, which is the Unity interface. Here, I'm only calling void system. I don't call agent from here, right? And all these 300 agents are managed inside the voice system. Yeah. So now we can do a little bit run test. So at this point, it shouldn't error. At least everything is there. Nothing, we see nothing, but it's not erroring. So what we did is we created a voice system. And I told voice system to create 300 agents. And inside voice system, when I just had everything created, I created 300 of agents in random velocity. Does it make sense? Does it make sense? Okay, so the reason why we want to have the separate voice because we want to manage unity geometry only in this tab. We don't want to mess around voice system or voice agent with unity stuff. Yeah. So the geometry thing we are going to do here. So let's create two different methods called voice setup geometry. Another one is update geometry. What I'm gonna do here is whatever voice system calculated the new locations of all the agents. I don't care what are those calculations. I will just use those location and velocity to replace the geometry. All right. So simply, I will just make a for loop. You can do int I and have like that, but you can also do it, write it like this. So void for, you can say for each, so we don't have to use number I, void agent in all voice agents. Dot agents. So this, I need to access all the lists, but probably in voice system, it's not public. That's why I don't see it here. That's why I go back to voice system and make this into public. And then come back. Now there's no error. So what this means is I'm declaring a thing called agent that is picked one by one from this list called void agents, which is this list. Okay, I'm gonna set up a geometry. I'm going to bring a public geometry game object. Public game of agent. I'm gonna call it agent prefab. We just made one. So I'm going to save. Going back to my Unity. And then give that prefab we just made here. Right, so now you have a prefab, okay? But we didn't do anything yet. So we are going to instantiate it like how we did it. We had this quaternion, right? quaternion rotation is quaternion dot loop rotation. And now we have this velocity to look at, which is pretty cool. And we don't have this velocity. This velocity is coming from agent dot velocity. Okay, and then I'm going to use game object. New geometry is instantiation of the prefab using the agent's dot position and the rotation. Does this make sense? So now I'm gonna call this function in the start. Okay, now we are ready to run it. We should see 300 cubes. And they are rotated. Got it? Got it? Okay. So let's also have this update effect. So firstly, my agent update is there, okay? In the void system, we have to let all of these agents to update. So I'm going to make a void. This has to be a public void update. I believe this agent, this one needs to be also public because I need to access from the system. And for each, again, void agent in agents. Going to let each agent to update. That's it. Now we are going back to our voids. And I'm going to copy this, Ctrl+C, Ctrl+V. And here, instead, I'm going to call yeah, actually I need to just copy paste all of it. No, I'm not. Oh yeah, I'm not instantiating, I'm updating. So what I need to do is, okay, so I need all of these geometries to be a list. Okay, it's a private list of game object. I'm gonna call it same as this. I'm gonna call it all agent prefab is new list of game. Then once that's set, I'm going to come here. And this is the geometry. So it's maybe better. it's better I use the count because I use both. So for int I is 0, I smaller than void agents count I plus plus. Make sure that we add these new geometries every time we create them. And then this is the geometry transform position. E is going to be my agent void systems agents I dot position. Before we do this, before we go through, yeah, actually, that's updating geometry. Just taking the position and translating that to cube's position. Before this, we need to update the void system. So now if we run it, I think it's too fast. So I'm gonna change this number to 0.2. It's just using one single velocity, but random. How do you find it so far? Too difficult? What is that? Positive or you lost? Everybody lost? Hierarchy is clear. So you want me to go through this first? Okay. Yeah, is that helpful? Should I explain this until now? Yes? It's okay. I can repeat this also. Right. Yeah. Sure. Yeah. It's actually a very advanced script. So don't worry. Don't worry if you don't get it right away. Okay? Hmm? Yeah. Let me share this for just right like this now. See if you can run it. So the current state of the script, void script, I'm gonna zip it. This is archive. Okay. Try this one. You just unpack it, unzip it, and put this folder in your folder, in your assets folder. All right, do you want me to explain it a little bit? Okay. So this utility is fine, right? This utility is just a bunch of things that we repeatedly using, so I didn't bother writing it. Okay, so we can forget about that one. Agent is clear, right? It's like, do you remember the human? How we made human? Human had ages and position and height. Those are properties. So we set two properties for agents, each agent. So consider the agent like one bird. Yeah, one bird will have one location and one velocity. Hmm? No, agent is like human. The object itself. So we are like a person, right? We are a person, and with 13 of us are a group, right? This group is called Architectural Technology Studio, right? Which in this case, it's Boyd system. So Boyd system is a classroom. In this classroom, we only talk about these people. We don't talk about other people. All right? And then we only talk about us in this classroom. And we determine what each person is capable of doing in the agent. Does it make sense? So if I were to change the name, I can change the Boyd agent to human. I can name it human. I'm just for a conceptual level. Don't worry about it. And then this one, I can call it class a studio class group, whatever. This is a group, and we only manage the group. So let's say in the Boyd, we did call Boyd system and made a name, declared a name called Boyd system, which might be confusing conceptually. What I could say is, okay, let's make a, what did I just call it? We called the studio class group. Is called architectural technologies. You can also make multiple systems and say this is fiction and entertainment. Right? So the system is the property of a class, but we don't determine which class it is. Does that make sense? Okay, cool. So let me bring it back. So this should be called Boyd system, and this is called Boyd agent. So in this specific system, we are, let me go back to this thing. So each of these is a system, is an agent. Every single one of them are called agents. We make agent and we will add some calculation relationship inside that. But this whole group is system, Boyd system, all right? But Boyd system doesn't have any geometry. It only does vectors. That's why we are adding one more called Boyd, It's actually should called main menu, for example. And that is using this information to replace for the unity geometry. That's why we have these three separated things. So in the future, what is possible is if you keep this system, you can actually copy these two C# scripts, literally only maybe changing the vector3 to something else that is in the Grasshopper, for example. And you don't have to change too much on these two or these three separated class, because only this one is dealing with unity. Okay? So all of these calculations can be repetitive used in different platforms. So that's why knowing this structure is kind of important. It's much more professional, but for our purpose, it could have been like more messy, like does the same purpose. But it's kind of, we are trying to start from a clean structure. That's why it's good that we understand it. Okay? But we can do it in just one class and adding everything like in a dirty manner and like become really long script. That's also possible. Everything good? All right. So if I wanna, so this is clear, right? Void agent. Nothing is difficult. Void system, inside void system. So this, what did I say? It's a constructor. So in void agents, this is constructor. In constructor, we only pass the local variable to global variable. That's the only thing we did here. But you can also do some for loop and other calculations. This is only called when you call this, when you say new void system. And then you said 300. That's why it created 300 of agents. But from this main menu, we don't care how they're generated. We just give the number, easy. Okay? Yeah, I know it's a bit difficult. I know, yeah. You might wanna go through this few more times, and I can also cover some other scripts. So you can kind of repeatedly kind of do this exercise. Do you need more explanation? So this geometry setup, is it understandable? So basically, if you don't care about anything else, so let's look at the start and update. So in the start, which is the first frame of the game, we generated the void system, right? We told this class to have 300 students, right? So when you call this in line number 14, it goes to the void system and call this line. Does it make sense? Okay, and then it came back, and then it calls setup geometry, which is under here. Only thing I did was to instantiate a new cube on every agent position. Is that okay? Okay, let's go back to update. In the update, I'm asking the void system to update. And inside that void system update, it's going through all 300 agents and update each agent. But in this tab, I don't have to care how that's done, right? I let agent voice system to do it. So when I call this line, this will happen every frame. It goes to voice system and goes to update, and it runs this line. And because I had for each and core agents update, that's why when it comes to this line, it goes down to void agent update and let each void agent to update their own position and store it. All right. Good. Good that you're following. And then there is update geometry. In update geometry, what I do is I use all of those cubes that I created in the setup geometry, and I'm just purely getting one by one and replacing their transformed position to the new vector, new position, new agent position, right? So this is a structure, and if you understand this, that's it, actually. Other additional things are all about adding this complex math for calculating. But understanding this structure is more important. How did that go? Is everybody okay? You are getting it? Nice. Okay, cool. I know it's a little bit difficult and back and forth. Okay. All right, so we updated our geometry. So now we should look at some behavior. So basically in blocking, there are three different things or behavior or calculation that determines the rule of the blocking behavior. So let's talk about separation. So what is a separation? It means, so you see this green triangle? That is the agent class. Think about it like that, all right? And what this class is going to do, what this agent is gonna do is we are going to tell this script, sorry, let me use this, to decide what is the calculation radius. So we are not going to look at everybody. I'm going to look only from me, like 2 meters, right? So whatever is within my 2 meters, I'm kind of trying to avoid, right? So these ones are very close to me, yeah, within 2 meter boundary. So I want to avoid. That's a separation. All right. So literal calculation of it is beside is, you see, I will get this vector and get this vector and get this vector, add all of them up, and then average. That will become this vector. That's how we are calculating. Okay. It's really straightforward, actually. And then let's look at the other rule. This is alignment. All right, what is alignment? So you see within this boundary, maybe the boundary should be bigger. So separation boundary is smaller, alignment and cohesion. Okay, that's the rule. And in alignment is maybe I will look up for like 5 meters around me. And if everybody's kind of going to similar direction, I'm not gonna go the opposite. I kind of wanna follow a trend of my neighbors. That's why if I was going this direction, right? I will have to turn my direction to this. How do you turn it? You find this vector and add it to this vector to find that. But then how do you find that vector? You use your neighbor's velocity and add it up and average it and delete, separate from this vector. Anyways, we will write that. But in any case, we will do series of mass and then make a function to do this one. So basically, you just have 3 different functions that work simultaneously in same time, and it creates blocking behavior. Okay, so this is cohesion. Cohesion is looking at the bigger group. So if I were aligning with my 5-meter radius, I should cohere with, let's say, 10-meter radius. Why? Because most of the flocking behavior, they don't want to be lonely. They normally get a trend of holding bigger group together. That's why in this bigger radius, if you see my neighbors, I want to go to their locational center, which is their location's average. And then I want to go there. So this is another vector. So you see all these 3 vectors eventually will determine this behavior. Yeah. And we can also kind of customize the strength of each 3 vectors to let them create different effects. So sometimes strong separation to create different porosities, sometimes alignment, so we can kind of change the sliders and play with it. All right, so let's start doing something about it. Okay, so let's go back to our void agent. Inside void agent, we should write a behavior calculation script called compute the desired velocity. Compute desired velocity. And actually, we need to determine one more local vector called desired velocity. The reason is this velocity is the final velocity after all of these calculations, right? But in each frame, we should calculate all these different rules and then save it in a small local temporal velocity. And then it's gonna refresh every frame. And then that velocity will be added up to this total velocity. That's why we will need a small, tiny private velocity, which is called vector3 desired velocity. So mind, note that this is private and this refreshes every frame. So it starts from 0 every time. So when we start to calculate this thing, we will let them start from 0. So .0. And then we are going to script separation, alignment, and cohesion. Okay. All right, so here I need to know one thing, because inside my agent, I don't know where am I belong to, which class I am belong to, right? I need to know my neighbors, right? That's why I need my void system, my parent void system to be recognized here. So here you wanna make a public void system called void system. Void system, what's wrong? Public void system. Void system. This is public. Wait. Hmm? Oh, thanks. Okay, so in this way, we can access all the information from here. Then once agent is created, I will have to give myself, pass myself to my agent. So I will have to tell my agent where it is belong to. So say agent dot void system is this. So this means this, myself, right? So once I generate a agent, I pass myself to agent, each agent. So each agent have their, know where they are from. Okay. All right, and because each agent all right, because each agent will have to find their neighbor. Okay, so let's, in the void system, let's create a private list. This one is actually helping each agent to get their neighbor in their neighbor distance, because we don't have to calculate all 300 or few thousand, because if you only give like 3 as a unit, then the calculation is massively reduced, right? So it's much faster. So we are going to help each agent to find the neighbor according to the distance. So the thing that we are going to return is a list of void agents. And find neighbor. And then basically void agent. Find neighbors. Return neighbors. And this is a new list. And here we are going to loop through each of the agents. So for each void agent, neighbor in agent. So basically, do you remember the green and blue triangle? So this is the way I'm determining what is the blue. We are creating a list of the blue agents. And we are going to test if the distance is my desired distance. So for each, if neighbor, there are a few conditions that we need to know. So the neighbor is not myself. So it's not the agent. And this NN means if you have multiple conditions, you can use AND, two ANDs. Okay, and then we have to test the distance in between. So how do you calculate the distance? You minus the positions of two vectors. So neighbor dot position minus agent dot position is the vector in between these two. And then we are going to check their square magnitude. So that is the length and squaring it for a more accurate comparison. And then we are going to set up a number called neighbor. Let me put it here. In the public float, neighbor put radius. That's the radius that we are going to check. And because it's of squared magnitude, we're going to double this. So this helps us to avoid comparing minus. Okay. So this means that if my position, if my distance with my neighbor is smaller than what I desire, then you do this. Yeah. So I'm going to add my neighbor. What is neighbor? So I only add these blue ones inside this. That makes sense? Okay. All right. And then I'm going back to my agent. So I'm gonna use this information. So the first thing is separation. In this separation, I'm going to make a vector 3 called separation vector. I will start by vector 3.0. And then I'm going to go to for each I need to get the neighbor. Compute. Okay. So I'm going to get the neighbor through this. So I'm going to have this neighbor list passed let me just do this for now. For now, I'm going to just do it like this. So list of void agents. Then I'm gonna call it neighbors, which is my void systems dot neighbors. Wait, this is wrong. Sorry, let me resync. Where is the code? Okay, so it's like this. Compute design, okay. So this compute desired velocity needs to be called in the void system update. So basically you compute first and then update. So let me copy this. So while in order to compute it, you need the neighbor list, right? So we are going to call this function inside the update. And then in here, you need to receive this information by list of agent, void agent, and neighbors. Okay, so that actually passes you all the blue agents. All right, and with that, what do you do? For each void agent in my neighbors, or in neighbors, I'm going to minus my position and neighbor's position because I want to get this vector. Oh, I want to get this vector. I told you earlier for minus, if you want to point to A, you minus A minus B, right? So that's why my position minus neighbor's position is this vector. Okay, so let's do that. Let's find my position minus neighbor's position, dot position, is the getaway position. So if you have more than one, you need to calculate all of them, right? So I'm doing it per my neighbor. So I have 3 neighbors, right? In this case. In the find neighbor script, we eliminated them. Does it make sense? Okay. now inside here, now if I have 3 of them, I have to make 3 velocity, 3 vectors in order to calculate this red vector. Are you okay? Okay. Okay, I'm going to make a name for this vector 3 and get away from each of the neighbor, and we have to add up all of them. Okay, and then there are a few more calculations, but I'm going to add this into, so this has to add up to the separation. Okay. So the separation plus is get away. And also the principle is that if they are longer, they are weaker. If they are shorter, they're stronger. It's kind of natural, right? So that's why we need to divide a magnitude. Get away. For B dot square magnitude. So basically a vector divided by their length. So longer, the weaker. And then desired velocity, finally, you add that up. Add this separation up here. So on and so forth. This is done for separation. And for each of this, scripts, you do some calculation and then add that to desired velocity. And then we have to do something here to use this desired velocity to determine the velocity of the pole. But is that structure okay? Okay. All right. So let's calculate the alignment. Vector 3 alignment. Starting from vector 3, 0. Because you want to refresh it every time. And then for each neighbor, I'm going to get their velocity, all of their velocities, and average it. So alignment plus is neighbor's velocity. And then after that, divide by the count of neighbors. So it's averaging. Because you need to do this because you need to average alignment is alignment divided by neighbor count. The reason this was erroring, because it's a calculation and didn't assign to anything, and you are using integer. So that's not good. So that's why I need to do this. Okay, and that's it. So we add this to desired velocity. Still cohesion. So vector 3. We are gonna calculate the centroid of my neighbors, and then pointing to that. So center is vector 3.0 for each neighbor. For each neighbor, we get we add everything, all the location, neighbor dot position, and then average. Neighbor count. That's the centroid, which is this point. And then I'm going to calculate this point. This point is center minus my position, right? So vector 3 cohesion is center minus position. And then add that up to desired velocity. Cohesion. That's more or less it. There are few more things to advance this. But most of the difficult part is done. That's it. Okay, so we have this desired velocity. After compute the desired velocity, everything is calculated once. And then we need to add that to this velocity. So we are going to say velocity is velocity. We keep some tendency of original movement, but add up this new calculation every time. So I'm going to give 97% of the original movement and 3% for changing the direction every time. So it's kind of slow. We can also give some maximum, like if velocity is too fast or too slow to do something. We can kind of really advance this more in detail with all these kind of things, but this is, let's say, basic. So let's see if we have it completed. So we are almost ready. Let's check. So in the voice system, we have an update. Whenever it's updating, we call compute the flocking vectors and then do the update. And then it's finding the neighbors every time with when every agent is asking for computing. This looks pretty good. I think we are ready. So let's play. something is wrong. So line, update geometry. Okay, now it's working. So basically, because sometimes there can be zero neighbor, right? Because it's too far. So I had to add a condition before I run all this flocking script, void script. I said if my neighbor count is zero, just use the original velocity. Otherwise, just calculate, because when neighbor count is zero, it's not gonna calculate. All right. And then next time we can start to add like sliders and some more control. But today, I think this is pretty much it. As long as you understand the overall concept, it's good already. Okay, now I'm going to share this. Save it. Okay. Once you have this, so now it's something fun. Just last few more things. Okay, so last few. Okay. So when you have this set, you want to set your game scene looks nice by hitting camera, Control Shift F. So you have a stunning game scene. You can easily change the background color by go to Window, Render, Lighting. Here you have environment. The default is skybox. I'm going to make a new material. Right click, create a material, and I'm gonna call it sky. And here I'm going to use cube map as a shader and change this color to whatever you want. And then use this as the skybox material. And you can also go to scene, go to use this one, light setting, new lighting setting. And why is it not letting me? You can just try to improve a little bit of how it looks like. You don't have to go too crazy on this. Go to field setting, player setting, and why these options are not, oh, because I was playing mode. That's why. You shouldn't do that. Okay, you always change things when you're not playing the game. Okay. Now go to your environment give the sky. And then let it generate the lighting. Okay. Didn't improve much, that's fine. Okay, so one more thing. So if you go to Windows and as package manager, and here, not in project, but let's see, Unity registry, let's see. And then search for record. So there is a recorder plugin library. So say install. Okay, so this is installed. Now you will see a new panel here in window. Panel, no. Where was it? General, recorder. And there is a recorder window. Just open this one. Okay, and this one, you can save some screenshots or record video or whatever. And then add a recorder, add a movie, and then set up a quality high MP4, that's good. And I believe you can also set the quality of it somewhere. So just have a look, and if you play, it's gonna play the game and record. And then now if you close the game, it's gonna stop recording. It's gonna record the game scene, not the scene. Then you go to your project. Recordings. Yeah. Now you have a movie, but I didn't set the correct size, I guess. It's in general, recorder window. Where can I set? Format. Oh, size. So I should have checked at least FHD or 4K. Minimum FHD. Okay, that's it. And homework. So everybody, please follow this tutorial. Yeah, try to understand as much as you can. When I was a student, it took me a long time to understand this. So don't worry if you don't understand. Make sure that this actually you can run it. Yeah, if I share a script, you can run it. You know where to modify little things, where to find the parameter. That's enough for us. All right. So just try to generally understand it. I don't expect everybody to be able to write it from scratch. It's unnecessary. Okay. Yeah. So homework. So there are 3 things. One is follow this and make a recording. Just try. All right. Change the color, whatever, the geometry, change the whatever prefab. All right. Now another thing is try to keep on watching the tech documentaries. Yeah. Starting from The Future Of, if you have a Netflix account. Explained was also good. I also mentioned Black Mirror to somebody, which is more fictional. But do widely search for latest technologies. Okay. So that has to be done throughout most of the semester. Just really like be interested in new things. Yeah. But it can be anything. Like it can be about energy, you know, energy production, or about farming, you know, or about food, or about living, or about work. You know, like it's so broad. Just find more broadly search. And at one point though, kind of record it in a Google slide. I'm gonna share, some of you already know how I manage. I'm gonna share a web page, where you guys will upload your Google slides in the same position, and then we can review it every time together. But for now, just make a Google slide for now and keep it for yourself, and try to, whatever you watch, when you find something interesting, throw it in there. Doesn't have to be nice layout for now, but I want to have this platform where we can communicate and see what kind of things you are interested in. Yeah, but don't be too narrow-minded. Yeah, do more broad research. Some of you are interested in car, or maybe like also interested in something else. Try to kind of broaden your interest. Yeah, so I want to see this video and a Google slide with some interesting tech. It doesn't have to be final. I just want to know what you're interested in. And also, if you know something from your own culture or from your own experience, we might help each other to brainstorm as well, to expose ourselves to new things. So it's kind of a parallel research, which will slowly become a core of your thesis development. But let's not rush though. Okay, but it's good that we start think about it.